Okay, so we already did some equation solving. There were 4 strategies that we talked about maybe Wednesday last week. They were on worksheet 9A, okay? We're going to review those 4 strategies and then talk about some kinds of questions today that you have not seen. Probably in Algebra 2 or definitely not yet in this class. All right? So the first thing, I think we did this last week, was one of the strategies, but honestly, I could be wrong. It's been a while for me too. This question right here is typed wrong. I don't think I fixed it on yours, did I, guys? It should say b to the x equals b to the y. So if you can take and rewrite something so that they have the same base, then you can just set the exponents equal. This is on 8A and it's written wrong on your notes, I think. Okay, if the bases are not the same and you have an exponent in the variable position, then you're going to, I'm sorry, if you have a variable in the exponent position, I totally said that backwards, then you're going to have to exponentiate each side or rewrite it. Everybody good? All right, so can we rewrite these as bases of the same number? You can't make 4 and 16 have the same base? They're both powers of what? 4 or 2. Yes. If you don't want to have to do anything extra, leave this as a 4 and rewrite this as what? What is that as a power of 4? 4 squared. Okay. What does this mean to do with those powers? Oh, guys, you're scaring me. If I have x cubed 3 times, it means x cubed times x cubed times x cubed, which is how many? So what did I do with those? Multiplied. So this is 4 to the 2x. Now, once they have the same base, what can I do with those exponents? Just set them equal to each other. They have the same base, so the exponents have to be equal. So I can just say, sorry, let me turn that dinging off, but x minus 1 equals 2x. If I subtract an x, I just get negative 1 equals x. If I plug it back in, I get 4 to the negative 2 equals 16 to the negative 1. Is that true? This would be 1 over 4 squared. And this would be 1 over 16. Is that true, guys? Anybody awake? Yeah. Yeah, that's true. So we're good. You don't want to exponentiate and take logarithms if you don't have to, because you're going to get decimal answers unless you do a bunch of really icky work. You're going to get approximations. All right. Yeah, this is a whole different world. We're going to factor. Does anybody have any clue how we're going to factor that? If e to the x, this is an e to the x squared. Does everybody agree that you would multiply 2 times x there and that's equivalent? Okay, so in the book they would teach this. You can call this u squared minus 3u plus 2 equals 0. So we took e to the x out and called it u. How will that factor? U and u minus 2 and minus 1. Okay? If you don't want to do u substitution, what we really did is we factored this e to the x minus 2 and e to the x minus 1. if you did u substitution and you replaced it with a u, you're still going to have to go back and put in e to the x. Whoops, sorry. Okay, now how do we play take your turn being equal to 0? We set this equal to 0, we have e to the x minus 2 equals 0, which means e to the x equals 2. How do you solve when x is in the exponent and you only have one x? Nobody remembers? ln, yep, Myra says take the ln of both sides. So if I do ln and ln over here, let me just rewrite it, sorry. Okay, this x can move out front, right, because it's an exponent. And what is the natural log of e? 1. So I just have x equals ln of 2, and that's an exact solution. Or you could give me a decimal by typing it in your calculator. Anybody have ln of 2 that can type real fast? I don't have my calculator on yet. Okay. Can you give me one more place? Okay. Remember there was another one here. We also had e to the x could equal 1, right? Did I skip setting it equal to 0? Are we good? If we took the log of both sides, move this out front, we'd have x times ln of e, which is just 1, so it's just x, equals ln of 1, which is approximately, can someone? Yeah, e to what power is 1 would be 0. So the exact answers, I'm telling you this because on the quiz, this question is on there and it says you have to write it as exact and approximate. The exact answers were ln of 2 and ln of 1, which you could also have just called that 0. And then the approximate answers were 0.693 and 0. And that one was already done on your paper, yes? They didn't even give you the approximate answers. All right, we'll practice some more of that in a minute. All right, when you have an x only in one place, we just did one like this. So what did we do? Okay, you could do ln again, or you could do log, it doesn't matter. But when you have an x in the exponent, you're going to need to take the log of both sides. So if I choose to do base 10, I'd have this. Then what? Okay, good job. The x moves out front. And then I'm trying to get x by itself. So what do I need to do with this log of 3? Divide. So an exact answer would say the log of 19 divided by the log of 3. The directions say go ahead. I guess it says round to the nearest hundredth. I think the quiz says thousandth. Yep. Yeah, what's your question? Oh, so like how much? Can we? If it starts as subtraction, we can condense it into division. But we can't, right, we can't. No, you can't, is what I'm saying. Okay. It's the log of 19 divided by the log of 3. And if you did ln of 19, close parenthesis, divided by ln of 3, you should get the same answer, okay? So it doesn't matter which kind of log, as long as you did it the same on both sides. Everybody good? 2.68? All right, part B, we are using our algebra brain first. So what do we want to do first? Add 6. And then we have e to the 8x plus 1 equals 7. Now with the x and the exponent, we're going to have to take the log of both sides. What kind of log do we want to do because it's base e? ln. So if we do ln e to the 8x plus 1 equals ln of 7, we can move this out front, 8x plus 1. And what is the ln of e? Just 1. So we have 8x plus 1 equals ln of 7. Now, if I was vicious and said you needed an exact solution, you would have to do what 2 steps? What do we still have to do to get x by itself? And? Yeah. So you'd write ln of 7 minus that 1 and then divided by 8. I'm okay if at some point you switch it to a decimal. Doesn't say exact on one like this on the quiz. But if you switch this to a decimal, subtracted 1 divided by 8, that should be what you get. All right. How come no one's writing these down? Are these all done on your paper? Yeah. Oh, okay. Sorry. ln of 7, close parenthesis, minus 1, enter, and then divide by 8. Is it 0.11, 0.12? They rounded? You got it? They had 0.12? Okay, this would have been exact right here. All right, now do you have some that aren't done on your paper? Yeah. All right. X's are in the exponent, but I don't want to take the log of both sides if I don't have to. Can I write these both as powers of the same number? Yeah, 3 is power 3, but 9 is also a power 3. We could rewrite 9 as what? Okay. And then what happens to the numbers up here? Yes, we're going to get rid of the base 3, but what do we do with this 2 in the x, just so we're clear? Yes, these are multiplied together. And then, yes, because they're both base 3, we can eliminate the base. So if I subtract 3x, I get negative 1x equals negative 4, so x equals 4. These should always check, but if you wanted to go back and type on your calculator 9 to the 4th, and over here if you put a 4 in, you'd get 3 times 4 is 12, minus 4 is 8. You could check that those are equal, and they are. What about number 2? Nobody? Can we write those both as powers of what? What power of 1/4 is 1/8? So 4 to some power is 8? No. We can write them both as powers of 2 or 1/2. Do you want to leave them as fractions, or we can leave them? Make this a 1/2, and it's 1/2 what? Squared to the 2x minus 1. You're going to have to multiply those still. Equals, and 1/8 is 1/2 what? 1/2 times 1/2 times 1/2. So it's cubed to the 11 minus x. Okay, so what I really started with was that 1/4 became 1/2 squared, but these guys are still multiplied up here, so I have a 2 times a 2x minus 1. Over here, 1/8 was 1/2 cubed, and it was raised to a power, so these powers are multiplied because I got them both to the same base. All right, can you solve that real quick? Oh, I can't apparently. Anybody else get plain old 5? Plain old 5, I said. Sorry. Did anyone else get x equals 5? How's that? Okay, so if I plugged it back in, I would have 1/4 to the 10 minus 1 is 9. And over here, 1/8 to the 11 minus 5 is 6. And you could type those in your calculator and make sure they're equivalent. Did I do it right when I plugged them back in? Does it work? What did I have, guys? 1/4 to the 9th. Thank you. Okay, they are equivalent. That's all we're doing was checking, but should work. Uh-oh. One more of these. What do 4 and 1/2 both can be written as powers of what? 2. This is 2 squared to the 3x minus 2. So we're going to have to multiply those exponents together. Sorry, I kind of scribbled that out. Looks like there's supposed to be a 2 there. All right, and over here, what power of 2 is 1/2? Good job, guys. -1 to the 2x. So we're multiplying the exponents. We'll have 2 times 3x minus 2 equals -1 times 2x. If you try to do these by taking the log of both sides, it's hugely messy and you're going to get nasty decimals at some point. Anybody else getting 1/2? Solve carefully. Did I do something wrong? If I plug it back in, I get 4 to the 3/2 minus 2, which is -1/2. So if I had 4 and I square rooted it and I put it in the denominator, would I get 1/2? I hope that makes sense to some of you. -1/2, right guys, means square root it and then it belongs in the denominator. Is that true? Okay. What do we have to do here? Yeah, we have to factor. We can do it as a u substitution, and if it's the e to the 2x is messing with you, what can we actually do first? Yeah, we could take a 2 out. We divide this by 2, we'll have 6 e to the x. Divide this by 2, we'll have 27. Now, are you more comfortable if I factor it with u's and then put it back to e to the x, or it doesn't matter? So we have a 2 out here. This is what we're factoring, guys. The middle term here tells us we're going to do an e to the x and an e to the x. I need you to understand why that becomes an e to the 2x. If I multiply e to the x times e to the x, you keep the base and add the exponents. Do you understand that that would become an e to the 2x? When you had x times x times x, you keep the base and add the exponents, and you got an x squared. So this is e to the 2x. All right. Now, what are factors of 27 that'll give us 6? Yep, we need a positive 6, so plus 9 and minus 3. If I foiled that back together, e to the x times e to the x would be e to the 2x, because you'd add the exponents. Then I'd have a minus 3 e to the x, a plus 9 e to the x, and a minus 27. Would that give me what we wanted? These would become plus 6, okay? So that was just my check. Now what? Yep, take your term being equal to 0. Can 2 equal 0? Nope. Can e to the x plus 9 equal 0? Can e to the x minus 3 equal 0? We'll find out. This would be e to the x equals negative 9, and this would be e to the x equals 3. Take the ln of both sides. Ln of e to the x. Well, the x moves out front. Natural log is just 1. Equals ln of negative 9. Anybody know what's going to happen there? I want you to recognize that you can't take the log of a negative number. So there isn't going to be an exact answer. Ln of negative 9 doesn't work, right? So the only answer is x equals ln of 3, or anybody have a decimal for me? Or even 1.1 if it said to the nearest tenth. I don't know what it said. Ln of 3, 1.086 or 1.099 or 1.1. Okay. Any questions? This little note over here does say you can confirm this solution by graphing. Okay, so you could have graphed this original equation, y equals, somebody remind me what it said, 2 e to the x, right? You guys could be trying this. 2x, thanks. Plus 12e to the x minus 54, was it? Oh, yeah, I gotta get out of there. I always do that. Okay, and we want to know where it equals 0. So if we graph it, where it equals 0 is here. It only shows 1 in this window. Okay, I could try looking at a different window, but we already figured out that it only had 1 0. And it's somewhere between, we'll say 0 and 2. 1.0986. Is that what we got? Okay. Now here's my question. Could we just solve by graphing from the beginning? Yes, except the quiz will say find the exact answer, okay? So you will need to show this work and show that you got ln of 3. But partial credit if you can at least graph it, right? You get a less of an error. All right. 2 questions here that have x's in the exponent. How do we solve those? Yep, take log of both sides. Anybody care which kind we do? Nope. I'm going to do ln. Doesn't matter. And I moved the 2x out in front already. Did I do that too fast for you? Should be ln of e, ln of 12. I'm sorry, ln of 9, ln of 12, and the 2x was up here and I moved it out front. All right, now what? How do we get x by itself? What are we going to divide by? Okay. Then we still have 2x. Yep. We'd have to divide all that by 2. At some point, you can just switch to a decimal. It's fine. So we have ln of, what was it, guys? Close parenthesis divided by log of 9. And then eventually we're going to need to divide that by 2. You could have done it in one step by saying, I'm going to take the log of 12, close parenthesis, and then I'm going to divide it by the quantity, 2 times the natural log of 9. Does anybody need me to do it with log to show you that it's the same thing? I promise. Okay. So I could have divided the 2 out here at the same time, as long as I put extra parentheses. All right, who's got the other one here? What do we have to do first? This is one where students get it wrong because they do the log first. What's the Algebra 1 brain telling you to do first? Yeah, you should be dividing by the 2.4 first. So then I have e to the x minus 6 equals, I don't know, is that going to come out nice? I'm not even going to bother to type it. I'm just going to leave it like that. Now what? Okay, so it is an ending decimal. Use all the places. Nolan, wake up. What are we going to do to both sides now? We need to take the log of both sides because the x is in the exponent, and we're going to do ln because we have a base e here. All right, and then when I'm all done, this is 1. So I'm going to need to do what still to get the x by itself? Yep. And you don't need to do an exact one-on-one like this, but there's the exact form. But you just need a decimal is fine. So we have ln of 9.3 divided by 2.4, close parenthesis, plus a 6. And you could do that in steps along the way. But it's 7.355 if you round at the end. Questions? If you rounded earlier, you might have gotten 3, 4 if you did 2 places and did it earlier, the problem. Or 3, 5, 3, 6. Depends how you round it along the way. All right. Number 7. Can I write those both as powers of the same number? 6 is not a power of 3, right? Nope. So then we have to do what? You have to do log of both sides. You can't divide. I'll write log this time, but it doesn't matter. Okay. Of 3, and the 2x comes out front, equals x minus 1 times the log of 6. I think we should change to decimals. Do you want to see how you would have to solve this exactly? Well, if you distributed this over here, you'd have the log 6 times x minus the log of 6. The parentheses either place here. And over here we have 2x log of 3. We need to get the x's together. I don't think you want to mess with that. Do you see what I'm talking about? It's a nightmare. So let's just change to decimals. Okay. Over here, could we multiply the 2 times the log of 3? It's all multiplied together, right? Times the x. Anybody awake out there? So do 2 times the log of 3 for me, because it's x times 2 times the log of 3, or the log of 9, but 954, okay? Equals, over here, what is the log of 6? Give me 3 places. 7. This is 0.778, and we need to distribute it in here. So we'd have 0.778x minus 0.778. That was not an exponent power, I just wrote. All right, let me rewrite it. So we had x here times 2 log of 3. We type that in. And over here, we had the log of 6 times x minus the log of 6 times 1, which is what became all this. Now what? What, huh? This is just 0.954x, right? 0.954x, I just wrote it in a different order, minus 0.778. Okay, someone help me. 6, 8.186, how did I do? Okay, well, I was closer than I figured I'd be. 0.176, subtracted correctly, and then divide. X equals negative like that. Okay. So if we went back to the very beginning to test this, are we going to get exactly equal answers on both sides? Possibly not, because we rounded along the way. So it was 3 to the power of 2 times, was it 4.42, guys? Or 4.24? Okay. So that's like 1650 on that side. The other side is 6 to the power of 4.42 minus 1. Did I do something wrong? Because those aren't even close to equal. 6 to the 4.42 minus 1. 3 to the 2 times 4.42. Okay. Oh, it was negative. It was negative. That's what's totally wrong. Okay. If I go back up here and I type it, as a negative, and if I go back up here, okay, dummy, you didn't hit enter. I go back and get this one, and I type it as a negative. Now are they closer to the same? That was a half hour of our life we'll never get back. It does check, okay? They should be very close together. Whew. All right, 8s real quick. Do we even need to do 8? What are you going to do to both sides? ln e, 19x comes out front. ln 23. So what do we need to do? This is 1, so we just need to divide by 19. X equals this, you could write exactly as this over 19. Anybody have the decimal already for me? 165. Anybody checking her? We good? Okay. All right. Then we have setting 2 properties of logs. If we can set 2 logs exactly equal to each other, 1 log on each side, then you can get rid of the logs. This is as if you have the log base b of x equals the log base b of y, then x has to equal y. But only if they're the same base and only if you have 1 log statement. This is not an example of that. This you would have to do what first? By the way, I would like you to write that. Quickly, guys. Algebra steps. What do we do first? Add 1. Then what? Then? Divide by 2. because of the 2 out front. Now we have the log base 5 of 4x equals 6. X, yeah, x off power. Okay, all we did was add the 1 over there and divide by 2. We didn't change anything here. We still have log base 5 of 4x. Now what? Not 2 logs. We can't get rid of it. We have to either rewrite it or exponentiate. I always think of it as rewriting. I say to myself, well, 5 to the 6th has to equal 4x. And I solve. But it's the same thing as your teacher last year taught you to put a big 5 down there. And then what happened? This took care of itself and you just had 4x equals 5 to the 6th. Is that not exactly what I just had, except mine was switched around? Okay. Somebody type 5 to the 6th and then divide it by 4 for us.
3, 9.
Okay. Was that one already done on your paper for you? Is that what they had? All right. This one is tricky, guys. You would have to, because this does not have a log. Does everybody see that? Okay, so I would add the 2 logs together to one side. Then what does it mean when you have 2 logs with a minus? This is when you need to condense, yes. Then you get log base 2 of x minus 6 divided by 2x. Now you want to exponentiate both sides. Giant 2, giant 2. So we have x minus 6 over 2x equals what? Anybody tell me what 2 to the 5th is? Okay, now what? No, yeah, you're right. Yes. Yep, thank you. Good thing you got this worked out on your paper because Hofbauer's messing you up. To get rid of minus, you would add, and what does it mean when it says add? Okay, now 2 to the 5th is, okay, what's happening over here? I have a 2x and an x minus 6, so I have to distribute 2x squared minus 12x. I'm going to subtract the 32 over here so that it's equal to 0. I can take out a 2. X squared minus 6x minus 16. How does that factor, guys? X minus 8, x plus 2. Does that work? Okay, does this 2 ever equal 0? No, so I have x equals 8 or negative 2. But we have to be super careful because can you take the log of a negative number? No, so I can't put a negative 2 back in. Is 8 even okay? 8 minus 6 is still positive, right? And over here, 2 times 8 is positive. So is that what your worksheet had? X equals 8? All right, sorry. Thank you for fixing me. All right, 9 is totally different question. It already says log on both sides. So we can just solve 3x equals 12 and get what?
4.
X equals 4. Can we do that over here, guys? Can I wipe out all of these logs? Only when you have 1 on each side. What are we going to have to do first? Condense. Yes, what can we do to combine these 2 into a single log? Yes, 2x. And then over here we have log base 12 of x plus 7. Now, do we need to do to the 12th power? I mean, to like base 12? You could, but it's going to go away on both sides. They're just equal because they're both the same log base. So we have 2x equals x plus 7. If we subtract, we get x equals 7. Everybody okay? Don't ask me for help later if you're not taking the notes, guys. All right, what do we need to do with this gobbledygook? Yeah, so we're going to have log of 16x plus 2 times 20x minus 2 equals log of 319x squared plus 9x minus 2. Can we get rid of the logs? Because we're down to 1 on each side. This would be 320x squared minus 32x plus 40x. I'm just going to subtract all this over to this side, so that it's equal to 0. This is 9. Don't we just get x squared plus 2 equals 0? Anybody keeping up with me? This is, oh no, this is 8, right? Yep, I'm wrong. That's a positive 8 right there. X minus 9x back here would be a negative 1x. So then it factors x minus 1 and doesn't factor? X minus 2. No, that's not going to give me a plus 2 though. Quadratic formula? All right, guys, we will finish these tomorrow, but this is what you need to be working on tonight. Okay, page 196. And then you need to tell me by the end of the day if you have something you want to retake besides 2.6 or 3.3. I will have those two ready to be retaken tomorrow, but you have to have the remediation sheet done to be able to redo them.